Hey, welcome again for our latest installment in the Tin Can Lectures. Yep, a little DIY setup. So we're going to do 5.7 and 6.1 this time, and I'm going to do them in two separate videos because they're both kind of difficult concepts to just read about and work on your own. These are probably the videos that'll be most watched. All right. So 5.7 talks about a negative exponent because if you remember, when we divide two things with the same base, we subtract the exponents. And when we subtract, sometimes we'll have something like 3 minus 5. And if we did, 3 minus 5 would be negative 2. So we have to understand what that means. Let's look at it, just a small example that's not on this sheet, just so you can see what I'm talking about. So x to the 3 minus 5 would be x to the negative 2. 3 minus 5, yep. So what does that mean? Well, if we were to look at it another way, x to the third is actually 3 x's being multiplied, and x to the fifth is actually 5 x's being multiplied. And for each one of these that are over each other, they cancel. 1, 2, 3 cancels, but we're left with 2 of them in the denominator. If we were putting them back together, it would be positive x squared, and then the invisible 1 on top. So what's going on is x to the negative 2 is actually the same thing as bring it down and change it to positive. 1 over x squared. Okay, so you don't have to do this every single time. You just have to remember that negative power means that he comes down into the denominator. So that's what's going on here. He comes down into the denominator. Now, the only thing that changes to positive is the exponent. The base number stays the way it is. That's important to remember. So in this case, when we have negative 4 raised to the negative 2, it's only the negative 2 that's changing, but they're all moving down. Now that it's down here and it's a positive exponent, you can actually do it and get 1 over positive 16, because negative times a negative is a positive. All right, little example. Separate that out for you, okay? That's number 1. Number 2, we have 1 over 5x to the negative 2. And what this is asking you to do is say, hey, well, first of all, 5 and x are not together, so don't involve the 5. Whatever happens with x, 5 is still down here. Okay? These are separate. But because he's already in the bottom, he ain't got no other bottom to go to, so he's going to go up here next to this 1. And you don't have to write the 1, but that's the answer right there. All I wanted you to do is move the x up. If it's already in the bottom with a negative exponent, it comes up with a positive exponent. If it's in the top, it comes down with a positive exponent, right? So, a few things to remember. Everything moves that has a negative power, and only the exponent changes to positive. I know the number changed to positive after you square, but that was coincidence because it was an even power. Okay? Okay. Glad everybody is with me on that. Some of you are like, what? In which case, you can just rewind maybe. You know, there's also videos you can find on, just Google, YouTube videos, math videos, negative exponents. There might be a person who can speak a lot more eloquently about this. In which case, hey, use it and send me the link so I can give everyone else this link. X to the negative 6 times x to the fourth is asking you to put together all the rules for exponents that we've learned so far. So that means that I have to remember that, whenever I'm multiplying two things with the same base, I'm actually adding the exponents. Negative 6 plus 4, different signs, subtract, keep the larger number's sign. So this ends up being x to the negative 2. And we all know what x to the negative 2 means. Negative 2 means bring him on down. I like to write the arrow. So it looks like this. All done. Okay. Number 4, we have what looks like a problem from the last worksheet where we have 6x to the 10th divided by 2x to the 14th. So if we remember from then, it is you divide the numbers in front and then you subtract the exponents, making sure that your answer is in the numerator. So 10 minus 14 is actually negative 4. So it's still a fraction. There's a 1 down here, but we have to remember that only the x is going to move down. The 3 stays where he is, just like the 5 stayed where he was when we did that. So same deal, 3 stays up, x moves down, becomes positive exponent, and we're all done. Right? Sorry I keep switching back and forth from boxing and circling. I don't know what I'm doing when I'm writing. All right. Okay, so there's just subtract. Make sure you keep the larger number sign and then move what you have to move. Don't move everything, just the thing with the exponent that's negative. Here we have x squared raised to the 3rd, and then it's being divided by x to the 15th. There's a funky looking x. I remember from my rules that anytime you have a power raised to a power, we multiply them. So that's first. X to the 2 times 3, or 6. And then we can divide these two by subtracting. So we get x to the 6 minus 15, which is actually negative 9. And again, because it's negative, he moves down and becomes positive 9. Going back to boxing. Okay. All right. Number 6. We have 5p to the negative 7 over 7p to the 2nd. So first thing I would notice about number 6, if I were working this problem, here you go, is that the 5 and the 7 don't really do anything. They don't divide. So, and then they don't move because they don't have negative exponents on them. So whatever happens with the p's, I have 5 in the numerator and 7 in the denominator. They don't do anything. It's just sitting there. Now here, if I wanted to, I could say subtract. Negative 7 minus 2. But if you can do that in your head, great. Negative 7 minus 2. If you want to write it right here, like in a little bubble, you can. So that you can see that, oh, they're the same sign. So I'm actually adding to get negative 9. Right? Keeping the sign, same signs add. Well, that means that p is going to move on down, and the 5 and the 7 are going to stay in the exact same place as before. Okay? So there's your answer, 5 over 7p to the 9th. Okay. One more on the sheet. Number 7. I saw number 7 and I was like, maybe if we were in class and I can come around and help you, I would put this on a quiz or a test. But since it's not happening, I didn't put this on the quiz. So you don't have to worry about this one so much. But what I want to show you anyway. So the thing is, with this negative exponent, he goes to the 2 and the x, and this 3 exponent goes to the 3 and the x squared, like so. So if I wanted to do that first, I could do that. I could say 3 to the 3rd, and I could say x to the 2 times 3, then I could say 2 to the negative 1, and then I could say x to the negative 1. We all know what happens with bases with negative powers. They move down. But these guys stay up here. So we end up getting 3 to the 3rd, which is 27. 3 times 3 times 3. And then x to the 6th. And then down here we have 2 to the 1st and x to the 1st, which I don't have to write. Okay? Not quite finished, but it's a lot, right, so far. We just gave everything their power, and then we moved the negative exponent things down. Now we're going to divide. 27 divided by 2, nothing happens. But this, 6 minus 1 happens. Happens all day. All day. And there you go. Okay? This is just one way to do it, too. There's another way that you could do it. There's probably a couple other ways you could do it. You could bring this down first, or you could have said 6 minus 1 up here to get x to the 5th rather than bringing the x down like we did for this one. Like we didn't bring down the negative 6. We just went ahead and added them or subtracted them. We could have... Nope, that's about it. That's probably the only other way you could have done this. Okay. Number 8. 6x to the 3rd times x to the 7th divided by 7x to the 4th. Now, this is one of those where they make it look like 6x to the third is together, and they're not. We know that now. We're better than that. We don't get tricked, hopefully. So we can see that with these numbers, 6 and 7, they don't divide. They don't do anything. So they're just going to be in the same place, whatever answer I'm about to get. Now, up here, I have a choice. I could subtract or I could add. Your choice. They're all x's. We're going to do one and then the other. How about that? So these I'm going to add first because I like adding. So 3 plus 7 is 10. And then I'm going to divide. I'm going to subtract. And then the answer goes in the top. 10 minus 4 is 6. There's nothing else to do. There's no negative exponent. Don't move nothing. Okay. All right. Y to the third over y raised to the negative 2. Now you get a choice here. Because when we work the order of operations, parentheses, whatever's inside parentheses can be done before anything else. So you could subtract first inside the parentheses. 3 minus 1 gives you y squared. And now you don't have a fraction anymore. That's why I want to do that. Maybe you too. Now, here you got a power raised to a power, and you remember that you multiply. Well, 2 times negative 2 is negative 4, right? Now we can deal with the negative exponent where he moves down and becomes positive. I don't know if you heard that. My voice went out. Been doing videos for other classes. Sorry you guys weren't first. I don't know. I'm doing my best. Okay, number 10. X to the negative 5 and y to the 6th. And that's being raised to the negative 1 power. Again, you have a choice. Oh, by the way, that previous problem, your choice here, you could have multiplied these two together and these two together, because you remember an outside power goes to both the top and bottom. But then you would have had 2 negative answers, and then maybe you could have flipped it, or you could have done negative minus negative. It gets complicated that way, in my opinion. This way, it's nice and clean. 3 minus 1 is 2. 2 times negative 2 is negative 4, and then move it. It's nice. With this one, I think it's probably better if you go ahead and distribute this little negative 1 to each one. That way, a negative times a negative, because remember we multiply, becomes positive. Hey. And then a positive times a negative becomes negative. Now, when you're deciding who moves, only the y does, right? The x and the y are not together, so x to the 5th stays up here, and y to the 6th comes down here, and you're all done. Because they're different bases, we do not subtract these two numbers. This is x, this is y, so leave them alone. All right, and that is what I have for you about exponents and negative exponents. It's a tough concept. One of the tougher ones that you'll have to do in quarantine, but hey, I didn't expect there to be a global pandemic this year, but I guess I should have. It was 2020. 2019 was tough, and we're like, oh, I bet 2020 will be better. That didn't work out. All right, so scientific notation. Basically, this number right here tells you how far to move the decimal. I think that was the very last thing I taught you guys. So we're going to move this decimal 3 places to the right. We're going to start, just write the number underneath, but we're going to go 1, 2, 3. And there's an empty space, so I'm going to put a 0 there. And there's your answer. 4,330. Not too shabby. And then we got 5.39, but it's 10, oh, let me write it, times 10 to the negative 4th. And this is telling you move the decimal to the left. So positive means move to the right, negative means move to the left. So if I write 539 and I start where that decimal was, I go 1, 2, 3, 4, and I put a little dot. Now there are 3 empty spaces, so I'm going to put zeros for all 3, and that is my answer. Those are quick, aren't they? Oh, you can't answer me? Oh. Okay, going the other way, though, can be a little tricky, but I've got a method that keeps it from getting confusing, or at least for me. So this is 74,000. I don't like commas when I'm changing to scientific notation, so I just don't write the comma. what I would do is I would put a little X where the decimal should be. So for scientific notation, you want numbers between 1 and 10. Now you can have it be exactly 1, but you can't have it be exactly 10. So what you want to do is you want to think about, if I put a decimal somewhere like here, that would be 7.4, and that's between 1 and 10. So I'm going to put an X here because this isn't the actual answer. I got to write 7.4 times 10 to the something. Now that times 10 to the something I find by knowing that the actual decimal is right here and by counting the number of places it is away, starting at the X. 1, 2, 3, 4. It's 4 places. So I'm going to write 7.4 times 10 to the 4th. So write the X where the decimal is going to be, and then count how many places it is from where the decimal actually is, starting at the X. So let's look at number 14 and get another example. 0.000, I think that's 3 zeros, 241. All right, now I need a number between 1 and 10, and if I put it right here, it's 2.41. That's between 1 and 10. That's where it should go. I'm gonna put a little X. And here's the actual decimal, so I'm gonna start at the X and go 1, 2, 3, 4. And it's 4 to the left, so it's actually -4. See, this is 4 to the right, so it's positive. And this is 4 to the left, and that's negative. And that goes along with what we were talking about up here. Not so confusing. So 2.41 times 10 to the -4 should be the answer for that one. Okay, this is just an introduction into scientific notation. If in intermediate algebra, your instructor, whoever that may be, needs to show you how to multiply and divide using your calculator, I think. Now, there are ways to do it by hand, but you get to use a calculator in intermediate. You get to use it here too, but don't tell anybody that. Okay, that's the end of that. Thank you.